Then we move on. Next presentation comes from Astronergy. Always glad to see women speaking in the still male-dominated solar industry, although I learned actually that the solar industry is performing best when it comes to gender towards women in the end, not only in the energy, but also among many other industries. Any case, I'm very happy to have with us Xuanyi Shi from Astronergy, and she will talk to us about how Astronergy is moving to TOPCon.
Thank you, Michael, and hello, everyone. My name is Xuanyi Shi, and you can call me Zoe if you cannot pronounce my name. Yeah, Zoe is fine. Let me share the screen. Okay. Can you see my slide?
Not yet.
Yeah, okay, let's start. Yeah. So my name is Zoe, and I'm the product manager of Astronergy. And in this year, Astronergy is planning to take a big step forward in the module manufacturing capacity, and its TOPCon module capacity will reach 34 gigawatt. And in my presentation today, I will talk about this topic from three perspectives. The first one is we choose mainstream product because it benefits from scale economy, high market acceptance, and high fast learning curve. So if we want to choose a big step forward, we choose the same direction. And then the second is to improve the product competitiveness in terms of the cell efficiency, cost reduction, module reliability, and energy yield. And the third is to provide customers with high values at the system level by evaluating the levelized cost of energy of various products. So here is the outline. So in the first three parts, I will follow by the perspectives that mentioned, and in the end, it's Astronergy's capacity. Sorry for that. I need to. Okay, so the first part is the industrial trend. So as you can see, there is an increasingly strong PV market demand. And in 2023, the global module demand is expected to reach 340 gigawatt. So this allows manufacturers to increase their capacity. And in last year, it's marked as the beginning year of high volume production of N-type technologies. And among these technologies, TOPCon takes the highest proportion, and it develops very fast. And last year is also the year that for wafer format change, it changes from 166 to 182. So when we say the mainstream product, TOPCon plus 182 wafer is very likely to be one of the dominant products in the next few years. And then in the second part, we talk about the product features and how we improve the competitiveness. Here is the module product of Astronergy. So the module iteration from Astro 1 to Astro 6 is basically the increase in wafer format. And currently we only keep 182 and 210 wafer format for mass production. And in last year, we also launched our TOPCon product, and it's made of 182 TOPCon cell. We have three panel sizes for our TOPCon module. The smallest one is for residential application, and the middle one is for commercial rooftop and utility scale. And the largest one is for utility scale. And comparing with the traditional PERC modules, TOPCon has several advantages, including the high power and high efficiency. So power rating is around 20 watts higher than PERC with the same panel size. And it has high energy yield due to better temperature coefficient, high bifaciality, and better performance at low light. And then regarding to the reliability, as we know, TOPCon has a lower lead-induced degradation due to the adoption of untapped wafer. And that's why the first year degradation can be smaller than 1%. And for long-term reliability, because the energy conversion efficiency of TOPCon is higher than that of PUC, and this allows TOPCon to operate at lower temperature, so the temperature-induced degradation can be smaller, and the annual degradation can be smaller than 0.4%. On the other hand, the model cost of TOPCon is currently slightly higher than that of PUC, and as Astronergy aim to bring this cost down to the same level of PUC by increasing the efficiency and reducing the cost. And TOPCon structure is essentially an ultra-thin layer of silicon oxide plus a heavily doped phosphorus polysilicon layer. And this structure provides excellent surface passivation and carrier selectivity, and also isolate the electrode from the silicon bulk. So it provides an excellent way to minimize the recombination on the rear of the cell. And in order to further increase the cell efficiency, we also introduced other improvements in the production, including a laser doped boron selective emitter to reduce the front recombination and the contact resistance. We also adopt advanced hydrogen passivation to passivate the surface and the bulk defect by controlling the hydrogen charge state and distribution. And we also optimize the front anti-reflection coating to reduce the front reflection without compromising the compromising the passivation by optimizing the silicon nitrogen oxygen ratio and also the thickness of each sublayer of the anti-reflection coating. And we also optimize the TOPCon structure to match with latter metallization process to further improve the efficiency. And regarding to the cell cost, there are still margins for cost reduction, including using thinner wafer, optimizing the finger design to reduce silver paste consumption, and we use a reasonable characterization method for process monitoring to keep to ensure the production yield. And we also develop single-sided polysilicon deposition to boost up the production rate. Then in the third part, we talk about LCOE evaluation. So from the end user perspective, LCOE would be very useful to comprehensively compare different products, because it not only considers the module cost, but also the system build as cost, operational expense, as well as the energy generation. And all this cost and the energy generation will be calculated into net present values. In this LCOE analysis, we compare three module products, including PUC 21066, TOPCon 18272, and TOPCon 18278. So the 210 and 182 refers to the wafer format, and 66, 72, or 78 refers the cell quantity. And here is the model information. So the power rating not only dependent on the panel size, but also the model efficiency. We can see that PUC 210 has high power rating due to large panel size, but its model efficiency is smaller than that of TOPCon. Then the open circuit voltage allows of 210 allows to connect more panels on one string. And regarding to the energy performance, as we have mentioned, TOPCon has several advantages. It has a lower temperature coefficient, high bifaciality, and lower degradation. So it allows TOPCon to have a high energy yield. And since we use bifacial modules, the lifetime is 30 years. Then we assume the price difference is 1 cent per watt. And please keep in mind that the latter LCOE calculation will be based on this price difference. we analysis this the LCOE in the scenario of ground-mounted PV power plant in Brazil with one portrait single-axis tracker system. We use ground coverage ratio of 0.33, and we assume the ground albedo to be 20%. Then we use DC to AC ratio of 1.1. And then this table shows the layout design of panels on one tracker. So in a very typical tracker, one portrait tracker design, we can either place 2 strings of 210 format panel or 3 strings of 182 format panel on one tracker. And this is because the length of the top tube is limited. And in this analysis, we assume it's smaller than 100 meters. And the number of panels per string is related to the open circuit voltage of the panel and the temperature coefficient of the voltage, and also the historically recorded lowest temperature. Then we can calculate the total quantity of panels on a tracker and also the total power on one tracker. And as you can see that PERC 210 has a smaller total power on one tracker because there is one string less. So now we got the model information and the system design information. In order to calculate the LCOE, we need to firstly simulate the energy generation by PV system. And here is the final result. So the lifetime energy yield of TOPCon is 3.3% more than that of PERC. And where does this come from? We break down the energy gain into contributors. Is 1% of energy gain from lower lead-induced degradation and 1.01% from better performance at high temperature, and 0.51% from high bifacial gain, and 0.78% from lower energy degradation. So that's energy generation. And then we look at the cost. The overall cost is composed of 3 parts: the module price, system BOS cost, and operational expense. So the operational expense is related to the module efficiency. For example, if we have high module efficiency, we can reduce the module area, total module area. So we can reduce the cleaning cost. That's why TOPCon has a smaller operational expense. And then the BOS cost is related to the system design. We will talk about this part in details in the next slide. You can see there is 1 cent per watt price difference. However, the overall cost difference is smaller than 1 cent per watt. This is because TOPCon reduces the BOS cost and operational expense. Then in this slide, we break down the system BOS cost into details so you can see where this difference comes from. It's mainly from 3 parts. So the first one is the module installation, and then the mounting assembly material for tracker system. So the tracker system cost, and also the DC electrical BOS. So the PERC 210 format panel has smaller module installation cost because it has high power rating, and also a smaller DC electrical BOS due to less cable consumption. However, the tracker cost for PERC 210 is very high. As we have mentioned, the power rating on one tracker is small, and this will increase the motor cost and the controller cost of a tracker to make the total tracker cost very high. So the overall BOS cost of PERC 210 is higher than that of TOPCon 182. And then we compare the 2 TOPCon panels. The 78 format panel has a smaller BOS than the 72 format panel. Then let's move back to the original equation. So the idea is that although we have 1 cent per watt price difference, the reduced BOS cost and the reduced operational expense will bridge this cost, bridge the gap. And if we bring the cost of TOPCon down to the same level as PERC, the benefit of TOPCon will become even straightforward. And more importantly, TOPCon has a high energy yield. And this is very important because it makes sure the possible slightly higher cost of TOPCon would be justified. Then we look at the final LCOE result. So with $1 per watt price difference, TOPCon still has a better LCOE result. And the LCOE reduction is 2.28% and 2.77%. So what do these numbers actually mean? Are they big or small? In order to make it more understandable, we also interpret the LCOE reduction into price premium. So the price premium is the idea that we increase the module price until we increase the TOPCon module price until its LCOE become the same as PERC, and the price adder is equal to the premium. So it's actually the values that we provide to the end user. And in this case, the premium is 1.7 cents per watt and 2.1 cents per watt. The previous case study is based on the Brazil project, and we also conducted other LCOE analysis in other countries. But I won't go through too much details here. And the final conclusion is that TOPCon 182 panel is preferable than PERC 210 panel from the perspective of LCOE. And in the last part is Astronergy's capacity layout. In 2023, Astronergy is taking a big step forward, reaching 49 gigawatts of total capacity, based on last year's 20 gigawatt. And in this year, 34 gigawatt is allocated to TOPCon capacity, accounting to 69% of the total capacity. And by the end of 2025, Astronergy has the ambition to reach a total capacity of 70 gigawatts. By the end of last year, we have 5 factories for mass production, and the Xuanyi factory was the newest one, and it started the mass production in December last year. And there will be another 5 factories built in the first half of 2023, and all of them will be ready for mass production by the end of this year. And that's all for my presentation. Thank you very much.
Wonderful, Zoe. Very interesting to see your cost calculations along LCOE. So you're also, I think we moved quite a bit. I think you will have over 2/3 of TOPCon production, and then you want to keep that for another while. Why do you want to keep for the next few years still some part in your portfolio?
You mean the capacity layout?
Yeah. Because I think most of the part you switch basically to around 2/3 of TOPCon this year. Then there's still a little bit of PERC, and that we will keep for another few years, if I recall correctly from the slide. So what's the plan? Why are you not moving fully to TOPCon?
Yeah, because it's mainly due to the market acceptance. So the market doesn't change that fast. Some of our customers do rely on PERC. And so we are still trying to introduce and educating our customers the benefit of TOPCon. So I hope they can accept it faster. Yeah.
Okay, thanks. I think we're running a little bit of time. There are questions in the chat, but I see that a colleague of yours is already answering them. Thanks a lot, Zoe, for this very nice presentation.
Thank you.
We continue.